All right, so today we're going to talk about graphing with limits. And in particular, what happens when we have an equation such as what you've seen with these limits. And let me just show you a couple of examples of what I'm talking about. Something like x minus 3 over x minus 2, or x plus 3 over x, and so forth. We're going to look at how to get to this point, but before we do, I want us to take a minute to understand how to graph using this chart, and then we'll look at how to develop this chart. That's my goal for today. So to begin with, I want you to notice how I have the chart set up. I have always set up with infinity on top, then negative infinity on the bottom. And in between there is a chronological step. In other words, I have 3 for both of them, but one's 3 plus, and of course that's closer to infinity, and 3 minus, meaning slightly smaller, and so that would be written as such. What that 3 indicates is that 3 means that there is a problem at 3 precisely, which is to say we need to figure out what's happening just to the right of it and what's happening just to the left of 3. Whatever this equation is, and I could probably take some guesses, but whatever this equation is, I know that at 3 it is undefined. So the way I'm going to draw this is I start with my axes, of course, and at 3, I am going to draw an asymptote, okay? And so what this says to me is, at 3, there's a problem. And what I'm going to be forced to do is to look at just to the right and just to the left. Now, again, looking at this chart, what we want to do is we literally want to group these in 2s. If you notice, our graph here has been split in half, one side of 3 and the other side of 3. And so I want to look at what's going on and I'm just going to start with this little section here. So just to the right of 3, it says negative infinity. Now, if I'm talking about y equaling negative infinity, what that's saying here is that y's are going down, right? Negative infinity would be down. As far down as so 3 plus, that means just to the right, I'm going to draw an arrow down. If instead I said, okay, infinity is approaching 0, then what this means is I'm approaching here towards 0. And I connect those 2 arrows together. Now, you don't know whether that's 0 plus or 0 minus just given by this chart. So we use the one that it's connected to determine whether it's on the bottom side of 0 or the top part of 0. All right, similarly, let's look at this next section. So 3 minus is going to infinity. Where would infinity be if y equals infinity? If y equals infinity instead, then that, of course, means we're going up. Good. And then this says that negative infinity is going to infinity also. So negative, that means the last thing, the very last thing on my graph, all the way to the left, that's really what that means when x equals negative infinity, that's left to right. So all the way to the left, I'm going to go also to infinity. And I just need to connect those 2. How would you expect those to be connected? Sure, it could be a parabola. It could be something, wavy. We have no idea because we don't have the equation to this. And as far as I'm concerned for you all, it doesn't matter to me how you're connecting it. When we get to calculus, we discover how the rest of that pans out. But for now, I just want you to connect the 2 arrowheads. Let's do another one. All right, so over here, let's look here to the right. Where is that asymptote that we're going to be drawing in here? Again, it's at 3. All right, and so now we're going to group these together. And so starting at 3 plus, that's going to infinity. So that means 3 plus just to the right is going up. Infinity is going to negative infinity. That means all the way to the right, it's going down. And I want to connect those 2. Again, we don't know how those 2 connect. They could have some weird bump like this. Oh, they could have a bunch of waves. Because you don't see the equation, our assumption could be any of those things. But we just want to, for now, just connect the 2. So I just do a little wave there. All right, 3 minus is negative infinity. So how would I do that? Good. Just to the left, I'm going to go down. And then negative infinity means all the way to the left of my graph, it's also going to negative infinity. And I want to connect those 2. We don't know how deep this parabola is. This could kind of come up here. It could kind of do that, or it could have the wavy thing going on. But again, it doesn't matter, just connect the 2 arrows. All right, last example before we do one in which actually forces us to do the equations. All right, so now, again, we're going to set up our graph. Where is our asymptote occurring? Good, -2. So we're going to label that. And we're going to group these together. -2 plus, that means just to the right, we're going down. Infinity, all the way to the right, is going up, and I want to somehow connect them. There, I'm just going to do a little wave there. -2 minus, that means just to the left, to negative infinity, and then approaching 0. And there you go. So that would be that graph. Now let's take a minute to set up our own table. What happens, and in fact, most of the time this is how it'll happen, because as I told you before, in the CLEP exam, they don't frequently ask limit questions. In fact, I don't think they've ever done that. But what they do is force you to graph something or ask you what this graph looks like. And therefore, the easiest way to do that, of course, is using limits. So, step number 1, okay? Step number 1. You will always, always, always evaluate plus and minus infinity. So when we set up our chart, the first thing I'm going to do is put infinity here, and I'm going to put negative infinity at the bottom. And so let's do that. Remember, that's just like a limits question. This is saying the limit as x approaches infinity, and I would have x minus 3 over x minus 2. So that would be infinity minus 3 over infinity minus 2. So we would have infinity over infinity. And does anybody remember what you do when you get infinity over infinity? Good. You take the highest degree from the top and the bottom. You simplify and retry if there's another x, which there isn't in this case. So therefore, infinity equals 1. How about negative infinity? So let's just change that up a little bit. Let's make this now negative infinity. So that would give me negative infinity over negative infinity, which is still infinity over infinity, right? We still take the highest degree from the top and bottom, and regardless of whether it's infinity or negative infinity, it also is 1. Now, where do we get the point in the middle? Well, the point in the middle is found by determining what number makes the fraction undefined. So in this case, what makes the fraction undefined? I hope you're saying 2. And so that would mean that I'm going to look at 2 plus and 2 minus. I want to look to the right of 2 and to the left of 2. We don't know what's going on at 2, but I can certainly figure that out based on limits, right? I'm just going to move this guy over here for a minute. All right, so let's do this question. So the limit that I'm going to look at then is the limit as x approaches 2 plus of x minus 3 over x minus 2. As I've said before, the numerator, it really doesn't matter in the fact of whether that's 2 plus or 2 minus. That's not why we have the 2 plus. The 2 plus is for the denominator, which we understand to be 0, 2 minus 2. But we want to, again, establish, is this 0 plus or 0 minus? And of course, 2 plus is larger, so therefore that's 0 plus. We know that a number divided by 0 plus would be infinity, but this is negative because of that -1 on top. Let's do another one. Limit x approaches 2 from the minus side. Again, the same equation. And so I would have 2 minus minus 3 and 2 minus minus 2. Again, it's still -1 on top. Again, that doesn't affect it. We know this is 0. But now we recognize that the 2, the regular 2, is the one that's larger, and it is negative. And so I have a negative over a negative, so that makes that positive infinity. Now let's graph it. So step 3 is to graph. Okay? So here we have our graph ready to go, and we want to put in place 2, right? That's where our asymptote is located, and then we're going to graph this. Again, we're going to group this into 2's. So I have 2 plus, or just to the right of 2, I'm going to negative infinity, so it's going down. And as I go to infinity, that means all the way to the right, I want to approach 1. So it's hard to recognize here for the first time, but that means that it's approaching what we call a horizontal asymptote. All right, now let's look at the next one. So 2 minus means just to the left, and it is going up or to positive infinity, and it's also approaching 1. on that one. Great. Let's do another example. Bring this guy over here now. All right. So let's start with our table. What's the first thing? Good. Infinity and negative infinity. If I put an infinity in here, that would give me infinity plus 3 over infinity. Once again, that's infinity over infinity. So I take the highest degree of the top. What's the highest degree? X. And the highest degree of the bottom. So this also, similar to the one before, is going to approach 1. What about if these were negative infinities? Still going to be 1. You're right. Okay, now where's the problem spot? What's going to make this undefined? 0. Yeah, 0, the very number there, actually makes this undefined. So I want to plug in 0. So I'd have 0 plus 3 over 0. And again, this would be 0 plus to start. So that would give me 3 over 0 plus, which is infinity. And if I had 0 on the minus side, then that still would be 3, but this would be 0 minus here at the bottom. And so that would be negative infinity. Now, as we graph this, we're going to group these together. And so we have our graph, right? And our asymptote, and just because it's hard to see here, I'm going to put it in a different color. It's at 0. And so I'm going to do 0 to the right is going up, and then we're going to approach 1. So again, I'm going to draw on that horizontal asymptote at 1. And then 0 minus is negative infinity, and it also is approaching 1. Notice I label not only where the vertical asymptote is on the x-axis there, but also when I have a horizontal one here at that 1, I'm going to label that also. So that's how you graph using limits, and we're going to work on this tomorrow in class. And then we're going to talk more about how to read the graph as well.